Okay, we're going to put this all together and look at story problems with trigonometry, because there's, again, these are some basic examples, but honestly, there's quite a few different real-life applications that have the same idea here. So we're going to go through about 5 of these and just walk you through them. One thing I would do is I always love to draw a picture. I draw a picture just to make sure I've got the right angle. Because the other thing is, if you for some reason didn't get what you're supposed to get, then at least you can look at your diagram, your drawing, and then you'll know whether or not it's the right thing or not. So, all right, so we've got from a point on the ground, 20 or 47 feet from the base of a tree. The angle of elevation to the top of that tree is 35 degrees. What's the height of that tree? So we've got this point here to the base of a tree here is 47 feet. And so we've got our tree here, whatever, however you want to draw it. And then we know the angle of elevation to the top. When it says angle of elevation, that's this angle, as you're elevating that angle. So this would be 35 there. And what we want to know is that height right there. We want to know x here. So now I've got my triangle. I'm looking for a side length, not for an angle, but for a side length. So I'm just going to identify what sides I have compared to my angle, and then substitute. So there's my angle. There's the opposite. The hypotenuse is right here, which I don't need anything to do with it, which means this is the adjacent. So opposite and adjacent, which is tangent. So I'm going to go tangent of my angle, which is 35. I'm just substituting here, equals the opposite side, which is x, over the adjacent side, which is 47. And then again, remember, we always find out what the tan of 35 is, or whatever this left-hand side is. So tan 35, I get 0.7002. That equals x over 47, and I can just times the 47 over in this case. And then I am done with that. So when I times that 47 over, I get x here, and this is 32.91. And that would be in feet, just FYI. So that tree is 32.91 feet tall. So really just do a drawing, and then you're good. Okay? Okay, we've got another one. We've got an 8-foot metal guide wire attached to a broken stop sign to secure it into position until repairs are made. Attached to a stake on the ground, the guide wire makes an angle of 51 degrees with the ground. So I've got this sign here. Okay, and it's broken here. I've got this wire that's attached to it down to the ground, into a stake here. The stake's right here. This is 8 feet here, and we know this is 51. And what we want to know is how far is the foot of the sign to the stake. So I want to know that distance right there. So there's my drawing here. Again, I'm going to say, okay, there's my angle, there's my hypotenuse. And then this is the opposite, so this has to be the adjacent. Say what trig function uses adjacent hypotenuse. That would be cosine, and then we're just going to substitute. So cosine 51 equals x over 8. And then I can just solve that like we did before. So cosine of 51 first, which gives me 0.6293. And then all I've got to do is times that x over, because my x is in my numerator. So this gives me 5.0035. And that's what x is in that case. So that distance from the stake to the base is, again, just over 5 feet from there. Okay, keep doing a couple of these. I got a flagpole that's 18 feet, casts a shadow of 12 feet. At a specific time of day, find to the nearest degree the angle of elevation of the sun at this time. So I've got myself a flagpole, and it's got the flag here, and it's casting a shadow because the sun's up here. And my shadow, let's see, this is 18 feet and this is 12 feet. And what I want to know is what is the angle of elevation, which would be this angle right here. I want to know what that angle is. Okay? So again, now we're finding an angle, so I know I'm going to have to use my inverse, but I still need to identify my sides compared to my angle. There's my angle, so this is the opposite. And then this has to be the adjacent because there's your longer side right there. So tangent, we go tan of my angle, which I just labeled X. You can label it whatever the heck you want to. Then opposite, which is 18 over adjacent, which is 12. And so if you guys remember, we have to use our inverse for this, which would give me X equals the inverse tangent of 18 over 12. If you guys don't remember that, then you might want to go back a couple ideas and make sure you're good with that. So the inverse tangent of 18 divided by 12. And so I get X is equal to 56.31 degrees. And this says to the nearest degree, so that would be 56 degrees would be the nearest degree, because that's not round down. Okay? Keep a couple more. Again, same process, guys. Draw a picture, and then figure out what side you have, then substitute, and then solve. On a windy day, a 90-foot rope tightly secured to a hot air balloon to stake. So you've got a hot air balloon up here. We'll see what I can do with here. Hot air balloon. Here's your basket. This is going to be the world's greatest hot air balloon. It is attached to a stake in the ground. Let's just say this is the ground here. There's your stake. And this is 90 feet. From the balloon, the angle of depression of the stake is 62 degrees. So that means, like, if I drew an imaginary, so we had a line here and a line here, this angle right here would be 62 degrees because that angle of elevation down there, that's 62, straight out down. So this is holding here, there's 62 degrees. We want to know the height of the balloon, assuming the the wind is constant. So I want to know how far this balloon is, which I want to know this distance right here. There's my 90-degree angle. Is this distance going to be the same as this distance here? So again, identify your sides. There's your hypotenuse. There's my angle, which means there's my opposite. So opposite and hypotenuse, sine. So I'd be sine of 62 equals opposite, which is X over 90. Too bad I didn't have any X's in the denominator on these ones. So sine of, again, 62. And that's going to give you 0.8829 all over X over 90, and then we just got to times by 90. So times that by 90, and I get X is equal to 79.47. 0.47. Bada bing, bada boom. Bueno. Now let's do one more. So we've got a shopper is standing on level ground, 800 feet away from the base of a 250-foot apartment building. So there's your 250-foot building, and we're 800 feet away. If we have this little dude here, and what's the nearest degree? What is the angle of elevation to the top? So we want to know this angle right here. Again, what sides do I have? This is the opposite. This is the adjacent. So tan of X equals 250 over 800. Again, because I'm looking for an angle, this is just going to be X is equal to the inverse tangent of 250 over 800. And so I just typed that in my calculator, second tan, 250 divided by 800, which that gave me 17.35, so 17 degrees would be the nearest degrees, 17 degrees there. Okay, there you go. There's your story problems. Don't be scared of them. That's good stuff here. So, Math Moment with Mommy out.